This is your transition metals practical, so I'm going to work through each of the metal sections in turn, carrying out the reactions on your sheets. You need to write down your observations and then write down the corresponding equations for each of the reactions that you've seen. So first of all, we have got our iron 3 chloride. So I've made up my solution and put it into 3 different tubes here. So to the first sample, we're going to add an equal volume of dilute sodium hydroxide. This is part A. So write down your observation. Think about making good quality observations as well. So not just the colour, what is the state and so on. So if I bring this closer to set you off on this one, we can definitely not see through it anymore, and we should be able to see some solid in there. So this we call the solid that's formed by the reaction of 2 solutions a precipitate. So we need a brown precipitate formed from an orange solution, and then you can put your equation in. Okay, I'll try and resist any more clues. Right, to this same solution, this is part B now, we're going to add sulfuric acid dropwise until there's no further change. I've got quite large volumes here, so I think we'll go more squirt wise. Done it big so that we can see the changes clearly. Pretty much there. One last one should do it. Bit of a shake round at the top. Okay, so to the second sample, we need to add potassium iodide solution. And record your observation there. And then for part D, we're going to add this stuff called potassium thiocyanate. And you've got the formula of the product on your sheet. Okay, this is quite cool. Thiocyanate can be used to identify the presence of iron 3, and we say it forms a blood red solution that's only at the interface there. You can really see. I'll give it a bit of a shake up there. There was supposed to be no more clues, never mind. Okay, so that's your iron 3. And now we're on to iron 2. So we've got our iron 2 sulfate solution here. So to the first one, we are going to add our sodium hydroxide solution. So have a look at that one and note down your observation. And then to our second one here, we're going to add some hydrogen peroxide solution. Now we should be able to hear that fizzing away, and you might like to think about, with hydrogen peroxide, what gas we're likely to have been producing. Then, as a bit of a spoiler, I'm going to see if this gas is going to relight a glowing splint. So I've got my splint glowing. There we go. Should try that once more as the splint's still glowing. Bit more of a glow on that. See if we can trap some of the gas and do it one last time. There we go. Okay, so I think we can safely decide that that is going to be oxygen there. Now, while we've been testing for the gas there, it's worth then just going back and having a look at changes that have occurred in this one as well. So can we see right at the top of the solution there, we can see a kind of brown colour. So it's worth considering what has happened to your iron 2 over time and why it is that that's mostly at the surface there that we can see that. So it's just kind of that surface layer that we can see. So with our left-hand two tubes here, we've got chromium potassium sulfate, also known as chrome alum. So that's our nice kind of violet coloured solution there. Okay, if we have a look up there, that's a nice colour to it. There we go. Right, so we are going to add, first of all, sodium hydroxide solution. And record the colour of your precipitate there. And to the next one, we're going to add ammonia solution. Now, our next solution here, this is going to be part 2. So this is potassium chromate. Okay, so potassium chromate with the CrO4 2- ions. Okay, so the formula of potassium chromate itself would be K2CrO4. So to this one, we're going to add a little sulfuric acid, and then we're going to add a little sodium hydroxide. So we've got our yellow solution there, sulfuric acid. There we go. And then what do we think is going to happen when I put the sodium hydroxide in? I need a bit more of that. And then if we wanted to, just for fun, we could put a bit of acid in. And then we could put some alkaline in. I'm going to regret doing the alkaline now because we intended that. There we go, getting there. I won't do that again, we'll end up with a very full test tube. Okay, you get the idea. All right, so have a think about what we're changing our yellow chromate ions into through that reaction. So our final batch is having a look at copper here. So we're starting off with our copper sulfate solution and then adding a few drops of ammonia, and then we're going to add our ammonia until it's in excess. So a few drops. And then excess. Let's go for pouring instead. There we go. Then to our second one, we are adding concentrated hydrochloric acid until this is in excess as well. So our concentrated hydrochloric acid here. Should be thinking about what you expect to happen when you add this as well. I've got a lot of copper sulfate in. Let's go for pouring this one as well. Okay, so we've got a little bit of graduation of colours all the way through there. So have a think about what colour you're seeing and why that is the case. Now I'm actually going to try and repeat this one again for you, just with a much smaller amount of our copper to start with, our copper sulfate to start with. I'll pour a bit more of that out, just to see if we can see the full change that you might have been expecting here. That one's kind of getting there. So have a think about what colour this one's a bit more like here. And then have a think about why this one would be quite green and this one is less so. So have a think about all of those colours there. Right, in our last one, we are going to add potassium iodide solution dropwise. So we'll see what that one does here. Okay, so we can think about what has been formed there. Delightful looking mixture. Okay, and then I'm going to add the sodium thiosulfate. Now think about what we normally use sodium thiosulfate to do. So which of our titrations and what is it showing the presence of? And so think about what is then going to react away as I add this in. And give that a good mix. Just a bit more. Still a hint of that brown colour in, so we get a couple more squirts there. There we go, so we'll leave that one to stand for a minute. Then our very last one, we have copper 1 oxide here. So we need to learn about the copper 1, but it's not one we use a huge amount. So to our copper 1, we are going to add sulfuric acid. And then observe any changes. So I'm just going to give this one a bit of a warm as well. So take this one over to the Bunsen. So after heating and letting this settle down a bit, we've got quite a distinct change here. So obviously we've got our blue solution, but actually we've got this solid being formed at the bottom as well. Okay, so it's quite different in its sort of particle nature to the powder we've put in the first place. And actually I've got another one over here that I think it shows up even better with. So this one I just did a second one and just put a bit less of the copper oxide in the first place. Okay, so think about what your solid is here and also what your solution is. So blue solution I think is a bit easier to work out. Then it's worth then just going back to part 3. So this was the one where we added our potassium iodide. It went all kind of brown and murky, and then we added the sodium thiosulfate. So after standing, we can now see clearly what the colour of our precipitate is. Sometimes it's quite hard to tell the colour of a precipitate while it's all kind of mixed up in a coloured solution because it appears to take on the colour of that solution. But now it's settled down at the bottom, it'd be worth just revisiting your observation for the precipitate there. Okay, now one last go to see if we can get this go all the way through to its final colour. So I'm going to pour out most of this and then I've replenished my supplies of concentrated acid. Okay, so we've just got a little bit of that left, and then I'm going to top up again with the concentrated acid, concentrated hydrochloric acid again. There we go. Third time lucky. I'm happy with that one. Okay, so we can think about what colour we ended up with here. So we started off with, that was part 2. So we started off with our copper sulfate solution here. Let's line them all up. We added concentrated hydrochloric acid and we ended up with it green, and then we added even more concentrated hydrochloric acid and we ended up with it being yellow. So have a think about what the complex is in the yellow one and think about why this one is going to be green.